The James Webb Telescope shows us the marvels of the universe in exceptional detail. As the most impressive space telescope ever constructed, Webb is 100 times more accurate than its predecessor, Hubble, and can easily see into the deepest mysteries of those structures that seemed completely imperceptible to the instruments of the past. And while the $10 billion gadget has already revealed one or two infinite secrets, it also uncovers the overwhelming beauty of the universe simultaneously, from smiling worlds to an infinite question mark and an unmanageable multitude of stars. Get ready to wonder at the developments of the universe in extremely sharp magnificence that will leave you totally dumbfounded. Smoking is undesirable, but space adventurers can't resist the urge to go after a stogie every now and then. Luckily, however, this particular stogie star doesn't release any toxic smoke, but rather intense bursts of star formation, which have now been thoroughly studied by the James Webb Telescope. Otherwise known as the cigar galaxy because of its unusual shape, M82 is famous for its captivating starbursts. Essentially, this refers to periods of fast and efficient star formation. However, most starburst galaxies are so distant from us that studying them in detail is quite challenging. Anyway, at a distance of 12 million light-years, M82 is a welcomed exception. And although the twisting galaxy in the Ursa Major constellation appears relatively small, it's a prolific star creator. In fact, multiple times more new stars are born here every year than in the Milky Way. However, past observations were often hampered by the thick veil of dust and gas that naturally occurs here. Webb's infrared view, however, is now able to break through these blinders and, with the help of its near-infrared camera, even capture images of the true starburst core. And while the dark brown dust veins penetrate the glowing white center of M82, even in this infrared image, Webb gives us the structure in an extraordinary level of detail. For example, we can see little red spots in the center, where young stars make subatomic hydrogen glow. The green areas, on the other hand, represent the opposite end of the heavenly flagpole. Most of these concentrated, iron-rich regions are merely cosmic explosion leftovers. The first brown dwarfs outside the Milky Way. Are they stars? Are they gas planets? No, they're brown dwarfs. In simple terms, these objects can be described as a kind of intermediate stage between a star and a planet. Brown dwarfs typically weigh somewhere between 13 and 75 times the mass of Jupiter. On one hand, they are too low mass to ignite hydrogen fusion inside them, but on the other hand, they are heavy enough for deuterium fusion to start. Surprisingly, these unconventional celestial bodies can sometimes float freely through space without being gravitationally bound to a host star, much like a planet. At the same time, brown dwarfs also share some characteristics with exoplanets, such as storm patterns and atmospheric compositions. And while Hubble has already shown us that the emission nebula NGC 602 is home to a series of young low-mass stars, Webb's sharp view has even spotted the first candidate for brown dwarfs outside our home galaxy. The small Magellanic Cloud is about 196,000 light-years away from Earth. And in the image, we see the open star cluster in a bright cloud of gas and dust in and around the gas cloud. Anyway, various distant galaxies also catch our attention, as do some stars that are much closer to us, and give the preview a glowing sparkle, showing the radiant beauty of the universe. Speaking of radiant beauty, compared to the image that Webb captured of Westerlund 1, the structures of NGC 602 almost look like diminutive fireflies located in the constellation of Changer, discovered in 1961 by the Swedish astronomer Bengt Westerlund. It's nothing less than the largest open star cluster known in the local group. A brief explanation: specialists refer to. Experts estimate that more than 1,500 supernovae will occur here in less than 40 million years. At the same time, Westerlund 1 serves as a star research laboratory for scientists to study extreme celestial physics. Here they can understand how the dance of the galaxies. It almost looks as though the two galaxies of ARP 107 couldn't be more happy about their fate. In detail, we are dealing with two interacting galaxies in the Leo Minor constellation, a good 440 million light-years from Earth. while the larger twisting and smaller curved galaxies are about to merge due to their cosmic dance. The orange and red star-forming regions, made of gas and dust together, form a sort of smiley face. But swirling structures are not the only thing that Webb has uncovered here. Thanks to the mid-infrared instrument MIRI, we now also know that a nearly simple white extension of stars is hidden here, detached from both galaxies. The main point, however, is that in a few 100 million years, the two cosmic partners will have merged to form an essentially larger, irregularly shaped. The Earth is around 26,000 light-years from the focal point of our home galaxy. However, the alleged dark clouds 1 and 2 are separated from the core of the Milky Way by a distance of 58,000 light-years. They are located in a region that specialists consider the super-outer system. A group of specialists used Webb's NIRCam to investigate specific areas of the two molecular clouds, revealing totally new parts of these remote areas, which conceal star clusters along with stellar nurseries. Although the two clouds are part of our galaxy, they are somewhat poor in elements heavier than hydrogen and helium. As a result of this composition, they are more reminiscent of dwarf galaxies or the early Milky Way. And while Webb confirmed the previously suspected presence of a subcluster in one part of the image, we also see weak planes extending in various directions from the bright structure. Music. The cosmic question mark. Many cosmic designs are joined by a giant question mark, and another, literally, as we can see in the next picture. The corresponding exclamation mark also seems to have a permanent place in the universe. In fact, the ESA stressed that the picture is by no means a fake or a scam, but rather a couple of already forming young stars, scientifically designated Herbig-Haro 46 of 47. And although the snapshot has the potential to become an iconic image, astronomers, unlike the Webb, are not making a big deal of it. Their main focus is on observing star development, offering a brief look into the planetary nursery, which is maybe just a reflection cloud in the Perseus star cluster. By definition, this is also another remarkable example of the essential processes that occur in the depths of space. Located around 1,000 light-years from Earth, the structure NGC 1333 is a tremendous star-forming region that is home to countless stellar infants younger than 1 million years. The mass of this region is estimated at around 450 solar masses. But that's not all, because while Webb's sharp infrared view also enters the dusty cloak in this case, we also see gas and dust plates in the picture, from which new planetary systems may arise. The secret complexities of M87. In a cosmic setting, M87 is just a stone's throw from us. However, even if the cosmic house cat would still need to cover a distance of 23 million light-years, it is one of the closest and most brilliant barred spiral galaxies in our area. This galaxy also has a central supermassive black hole. But interestingly, this one seems to be especially active compared to the massive beast at the core of the Milky Way. It gobbles up significantly more material, and while the unusual monster actively consumes dust and gas, M87 also has another surprising feature. It has two additional odd arms that are only visible in the radio and X-ray ranges, not in the visible spectrum. This is because these arms are not made up of stars at all, but of hot gas. Astronomers suspect that their existence is due to some kind of feedback effect from the black hole. Exhaustively, they are likely formed by outflowing material, which is created by the fierce flow of gas around the gravitational beast, and in turn, sets a process in motion that can be compared to a wave hitting a rock near the shore. The cosmic gem ring, where the gravitational lensing effect meets a distant quasar. The end result is an image suggestive of a ring set with gems. In simple terms, gravitational lensing causes the light beams of distant sources to be impacted by objects that seem to lie in front of them. In this context, the designs behind them can be optically broadened, distorted, or, as in this case, duplicated. Exhaustively, we see here with RxJ131D231, a functioning cosmic core 6 billion light-years away, which is affected by the strong gravitational field of a curved galaxy before it. The cosmic gravitational lens presents itself as a small blue dot in the middle of the ring, while the orange glowing diamonds show very similar versions of the quasar in different forms. For researchers, however, the gravitational lensing effect is much more than just an optical trick. After all, it rarely makes objects visible that would otherwise be far too distant or too weak to be studied in detail without this natural effect. And if you now look below our video,